let's take a look at powers. If I have 2 cubed, 2 is my base, 3 is my exponent. Since the base is 2, this is called a power of 2. Powers represent repeated multiplication. So 2 cubed means 2 times 2 times 2, or 8. 2 squared, when evaluated, would give me 4. 2 to the exponent 1 is simply 2. Okay. If I take a look at the pattern here, when the exponent is decreased by 1, I divide the numbers on the right-hand side of the equal sign by 2. If I continue this pattern, I would get an answer of 1 when the exponent is 0. So 2 to the exponent 0 is 1. If I look at powers of 3, the same thing is going to happen. 3 cubed is 27, 3 squared is 9, and then 3 to the exponent 1 can simply be written as 3. Dividing by 3 is the pattern that I'm following here as I'm decreasing my exponent by 1. So 3 divided by 3 gives me 1 when the exponent is 0. In fact, any base raised to the exponent 0 is equal to 1 other than 0. Okay, so 1,000,000 raised to the exponent 0 is 1. 1,000 raised to the exponent of 0 is 1. Okay, let's extend this concept or this pattern to see what negative exponents represent. Okay, so if I have 1 and I divide by 2, I get 1/2. If I divide by 2 again, I get 1/4. And 1/4 divided by 2 is 1/8. Okay, so negative exponents really represent fractions with a numerator of 1. Another way that I can write these fractions is using a power of 1/2. So 1/2 can simply be written as 1/2 to the exponent 1. 1/4 can be written as 1/2 squared. And 1/8 can be written as 1/2 to the exponent 3. Okay, so if I focus here, just to verify that 1/2 squared is equal to 1/4, I write 1/2 squared in expanded form as 1/2 times 1/2. Then when I multiply fractions, I know I have to multiply the numerators and denominators to give me 1/4. Okay, if I have 1/2 cubed, means I'm multiplying 1/2 by itself 3 times. Multiplying the numerators gives me 1. Multiplying the denominators, 2 times 2 times 2 gives me 8. Okay, so 1/2 to the exponent 3 is 1/8. So we verified that in fact these powers are equivalent to these ones. So if you were ever asked to rewrite powers with negative exponents using powers with positive exponents, in order to evaluate, you would have to take the reciprocal of the base, since 1/2 is the reciprocal of 2, as 2 can be written as a fraction of 2/1, and then change the exponent from a negative to a positive. So here, if I have 3 to the exponent -1, I can rewrite it as the reciprocal of 3, or 1/3, raised to the exponent of 1. This can be rewritten as reciprocal of 3 raised to the exponent of +2. Okay, this one can be written as 1/3 raised to the exponent of +3. In order to evaluate these, well, this simply exponent of 1 is implied. You can just write it as 1/3. 1/3 squared means 1/3 times 1/3. So really, you're multiplying 1 by itself. So you can write it as 1 squared. And then you're multiplying 3 by itself, which is 3 squared. And evaluating, you get 1/9. Okay? Here, you get 1 cubed over 3 cubed, which gives you 1/27. Okay? So first rewrite powers with negative exponents using positive exponents, and then you can evaluate. Notice since your numerator is going to be 1, you can actually skip this part here. Okay, so I'll show you. If I have, like, for example, 3 to the exponent -3, I know I will always end up with 1 in the numerator. Okay, the denominator would just be 3 cubed. I end up with 1/27. That's when the base is a whole number. If the base is not a whole number, you can't use the shortcut. Okay, if the base, for example, was, let's say, 2/3, okay, Then you would have to take the reciprocal of the base, okay, change it, the exponent, change the exponent from a negative to a positive, and then understand to evaluate that you're multiplying 3 by itself 3 times, then 2 by itself 3 times to give you 27 over 8. So there's no shortcut when the base is not a whole number, okay, or integer in this case. Okay, so now let's look at some examples. It says evaluate each power, express your answer in rational form. And remember, rational form is just fraction form where you can have negative and positive values. So the first one, in order for us to evaluate, we need to rewrite using positive exponents. Now, of course, you can use your calculator and enter what you see, but you need this in grade 11. You need to be able to do this without your calculator. So you're going to rewrite this using positive exponents first. So we take the reciprocal of the base. The reciprocal of 3 is 1/3. Okay, and we change the exponent from a negative to a positive. And then we'll end up with 1 to the exponent 4 over 3 to the exponent 4. And evaluating each of these will give us 1 over 81. Okay, now you could also, if you didn't want to do it step by step like this, like I said, you can use a shortcut. So you can just, if I have 3 to the exponent negative 4, you can write it as 1 over 3 to the exponent 4, like this, because you know since the base is a whole number, your numerator will end up being just 1. 1 raised to any number is 1. And then evaluating the denominator gives you 81. If you're not sure how to get 81 from 3 to the exponent of 4, you can use your calculator to evaluate for now. But the common ones you should know. On your calculator, depends what kind of calculator you use. Some of the calculators will have this button, okay, to use for exponents. So for me, for example, I would enter 3 exponent button 4 and hit enter to give me 81. But on your calculator, you might see some buttons that look like this. This is your exponent button. Okay, so look for something like that, maybe on your calculator to evaluate powers. So to evaluate 3 to the exponent of 4, you would first put 3 in your calculator, followed by your exponent button once you determined what it was, followed by 4, and then equals or enter, whatever button you have on your calculator. Okay, let's look at the next example. First, we're going to rewrite using positive exponents. I'm going to use the shortcut because I know my base here is an integer. So I end up with here 1 over negative 4 and squared. And negative 4 squared is positive 16. Okay, next one. Same idea, 1 over negative 10 to the exponent positive 3. Negative 10 cubed, okay, means you're multiplying negative 10 by itself 3 times. Because I have an odd number of negatives, my final answer would be negative. So I'm just going to put it in front of the entire fraction. You can also put the negative sign in the numerator. We don't typically leave it in the denominator. Okay. The next one is an interesting question because the base is actually positive 2. Okay, if it was negative 2, it would have been in brackets like in the previous examples. So this is telling me that this entire power here of 2 to the negative 6 is negative. So I still have to keep the negative on front. Then I have to rewrite 2 to the exponent negative 6 using positive exponents, which becomes 1 over 2 to the positive 6. And if I evaluate 2 to the exponent positive 6, I get 64. Okay. In part E, I take the reciprocal of the base, which is 5, and change the exponent from a negative to a positive. So 5 squared, when evaluated, gives me 25. Here, reciprocal of -1/4 is -4. I change the exponent from a negative to a positive. And this means -4 cubed, and I get -64 because I have an odd number of negative signs. Take the reciprocal of the base in this last example, so 7/6. Change the exponent from a negative to a positive. Understand that this means I'm multiplying 7/6 by 7/6, so I have to multiply 7 by itself and 6 by itself to give me 49/36.